The first application we're going to look at shows you the graph of a function, but we don't know the equation of this function. The function that you are working with, A of t, represents the number of people employed by a company from the years 2002 to 2014. T is the number of years after January 1st of 2002. So that would be when t is equal to 0. Now, that's not the function you're looking at, though. The function you're looking at is a prime. So this is the rate of change of a. This tells you if your function a is either increasing or decreasing or remaining constant. So remember that a function, in this case a is increasing when your first derivative is positive. So if I represent that on here from 0 all the way to where t is equal to 4, that would represent the part of function a that is increasing, right? Because that's where the first derivative is positive. Positive first derivative means that it's above the x-axis. So in that case, a is going to be going up. The next part of the graph that goes from t equals 4 to t equals 8 is underneath the x-axis. So if a prime is negative, that means that a is decreasing. Okay, so don't think of this particular picture or graph going up or down. Think of what that means in terms of its previous function. Okay, so then once again, from t equals 8 to t equals 10, my a function is increasing, and then from 10 all the way to 12, my function a would be going down. Okay, and so this tells you where the critical points are. At 4, there's a critical point, either a max or a min. At 8, there's a critical point. At 10, there's a critical point. Those are your peaks and your valleys. Okay, so at 4, at t equals 4, we have to determine if that's a peak or a valley. So right before 4, your function's going up. Right after 4, it's going down. That makes this number a relative max. And then at 8, you are changing from decreasing to increasing. That makes 8 a relative minimum, and then 10 would be a relative max. Okay, so understand that before we get too far into this. Once again, t equals 0 represents the year 2002, and so t equals 1 is 2003, t equals 2 is 2004, t equals 3 is 2005. It's a little bit confusing because the numbers don't match up like you had probably hoped. Let's go a little bit further. This is 2006. This is 2007. 2009. Don't have enough space in there, so I'll just put 2014 at the end. And so that's going to help us out when we understand how to interpret the questions that are going to follow. Okay. Oh, one more thing. The areas that you see indicated, let's do this. The areas that you see highlighted, I'll highlight appropriately. The area that is between 0 and 4, okay, I've highlighted in blue. That quantity of area is 2002, okay, and I highlighted it in blue because it's above the x-axis. So the area between 8 and 10 is 56. That's also above the x-axis. Let's identify the area that is below the x-axis. We'll highlight that over here. The area below the x-axis is 189 within that region, and then 50th within that region. So that'll help us out to decide if we should be adding or subtracting these quantities from one another. All right, let's go. During this 12-year period, between what years is the company losing employees? Between what years is the company losing employees? And so that means that the function a would be going down, right? If you're losing employees, your function is going to be going downwards. So that would be between t equals 4 to t equals 8. Okay, and then from t equals 10 to t is equal to 12. Now, corresponding to years, okay, we're going to say that that is from the year 2006 to the year 2010, right? And then from, let's see, when t is equal to 10, that corresponds to the year 2012. So from the year 2012 to the year 2014. All right, so we're looking for the parts of the graph that are beneath, the parts of A prime that are beneath the x-axis. All right, part B says, at the beginning of what year during this 12-year period did the company have its lowest number of employees? Okay, show all your work or explain your answer. The company is at its minimum number of employees. Now, this is not the minimum part of the A prime graph. Don't get confused. We want to know when the function of A is at its lowest. Okay, so we're looking for maybe its absolute minimum location. In what year does that occur? So think about what's happening at the beginning. At the beginning, in 2002, I am hiring people at my company. The number of employees that I'm accumulating is going up, and this continues to take place until 4 years later. Okay, till 4 years later. Then now, all of a sudden, I cannot hire anybody else. My number of employees is not getting any larger. In fact, it's turning around and it's going down. I'm firing people, or I'm laying off people, or people are leaving the company. The number of employees is going down. So let's think about what just happened. From the 0 point until the t equals 4 point, I've increased my number of employees by 202. And so maybe mention that here from t is equal to 0 to t is equal to 4, that first section of the graph before it crosses the x-axis, the number of employees at this company increased by 202 people, okay? And so I've hired a total of 202 people during that time frame. All right, great. Now I'm going to start losing employees. They're leaving the company for whatever reason. And so from t is equal to 4 up until t is equal to 8, I've lost. The number of employees has gone down. The number of employees has decreased by how many? And that's the area, 189. So I went up by 202, but then I just went down by 189. Okay, so keep a running total of what's going on here. Maybe your running total change. I'm positive by 202, okay? But during the next time frame, I've lost 189. So what are you at now? I'm still up by, from the beginning of this time, I'm still up by 13. I haven't lost everybody that I started hiring back in 2002, but I'm only up by 13. Great. Then from t is equal to 8 over until the next turnaround point, which is at 10. During that little time frame, that time span, the number of employees has gone up. All right, I've hired an additional 56 people. Okay, so I'm going to be adding that now to where I just left off. I left off with 13 employees up from 2002. Now I can include an additional 56 people to that group. And so now I'm up by 69 people. So this is positive, and this is positive, and this is positive. So far, I'm not below the number of employees I had at the start of 2002. I'm still up above. Then what happens? From t is equal to 10 to the end of this graph, t is equal to 12, I've lost people. The number of employees during this time frame went down by 50 individuals. Okay, so I'm going to subtract 50 from where I previously left off on my total change column. And now I'm up by only 19 people. Okay, so at what point in time did you bottom out? When was the lowest number of people employed at your company? It does not matter right now where you're starting that graph. Okay, that's irrelevant for this argument. I just want to know at what point between 2002 and 2014 was I at my lowest number of employees? And you can see that that's happening right here. Once you're up only a total of 13 from that beginning of the time frame, that's your lowest point, right? So this is where the minimum happens. Minimum happens at the beginning of T equals 8, and that corresponds to the year 2010. So how much space do I have? Good. When T is equal to 8, this is the year 2010. Whoops. I did it again. Let's try this one more time. 2010. There. In the year 2010, at the start of the year 2010, I am, the number of employees, let's say, the number of employees is at its lowest. Okay, and when we're talking, we're not considering the entire history of the company. We're just talking about the time frame from 2002 to 2014. Within that time span, at the beginning of the year 2010, which is where T equals 8 picks up, the number of employees is at the lowest. All right. Part C. At the beginning of what year during this 12-year period was the rate of change in the number of employees per year at its maximum? So 2 things to notice. Rate of change needs to be at the maximum. And this is great news because rate of change in the number of employees, well, that's just talking about A prime. So when is this graph A prime at its highest? And that's pretty obvious. The peak of this graph occurs right here. That's when the rate of change is at the highest, and I'm going to estimate that to be when T is equal to 2. So T is equal to 2 is when this happens. And so that's the year, that's the start of the year 2004. And that's pretty much all you have to say on that. Okay, the rate of your hiring is at its highest. That would be kind of an inflection point on your graph of A, okay? Because that's when the rate is increasing the highest. Part D, how does the number of employees at the company change from the beginning of 2006 to the beginning of 2012? So 2006 would be when T is equal to 4, and 2012 is when T is equal to 10. So we're straight on that. How does the number of employees at the company change between those 2 values of T? So 4 to 10, where are we at on my graph? From 4 to 10, we are down. From 4 to 8, we go down 189. But from 8 to 10, I increased by 56. So let's go. I lost from T equals 4 to T is equal to 8. We lost 189 people. But then from T is equal to 8 to T is equal to 10, I gained 56 people. And so overall, where are we at? Okay, I'm at negative 133 for my cumulative total. And so from, we'll say between 2006 all the way to 2012. Man, it's not my night, you guys. Number of employees decreased by 133. Some rough times. All right, let's see. This problem continues on the next page. So flip it over. And part E says the company had exactly 2,200 employees at the beginning of 2002. When this data was started to accumulate, I had 2,200 employees. So based on that starting figure, find the number of employees at the company at the beginning of 2014, which takes you all the way to the end of this graph. By the time the graph is all said and done, starting with 2,200 employees, the graph's gone up and down a few times. What do you have left? And so if I have 2,200 to start, okay, what happens? I'm going to flip my notes back here off to the side so I don't have to move my screen. What happened over the course of time? You've already done a lot of this work, but I'll repeat it here. I increased by 202. I went down by 189. I went back up 56. I went down by 50. And if you work it all out, starting with 2,200 as your starting number, your employee count is 2,219. At the start of the year 2014, right? And that makes sense. If you back up, it's going to tell you in part C, nope, part B. That's what we found in part B. We found that by the end of the function, by the end of the entire graph, from start to finish, I was up by 19 employees. However, I didn't know at that time what the starting figure was, but that when that graph began. So now I can take that 19 gain of employees and just add it into 2,200 and get that same answer. So you could have worked out the math here in part E, or you could have referenced your answer from part B that we just talked about. Okay, part F, evaluate and interpret the definite integral in terms of this application. So we're going to take the integral from 0 to 4 of this function a prime. From 0 to 4, I need to scroll up, sorry about this. From 0 to 4, you're discussing this piece. Okay, and so the integral from 0 to 4 is just going to be the quantity of area under that piece of the graph. And you can see that it's completely positive. It's all above the x-axis, and that was calculated to be 202. So we're going to say that down here. We're going to write our answer as the definite integral from 0 to 4 of this function a prime with respect to t is going to be 202. Interpret what this answer means in this context of the application. You're going to tell me that from 2002 to 2006, don't forget that's t equals 0 to t equals 4. The number of employees increased by 202. This doesn't tell you the total number of employees. This tells you the change in the number of employees. I'm increasing my employee count by 202. Good enough. All right, so problem number 2, I'm going to assign as your quiz problem. So this quiz problem, I extended the deadline just because I was late in getting these notes out to you. The quiz problem for section 5.3 is due Monday, April 20th at 8 a.m. And I recommend those of you who are not early risers, go ahead and get that done Sunday night so you don't have to get up early just to turn in your work. So yeah, Monday the 20th of April at 8 a.m. Please get this problem turned in to me. I uploaded the Word documents for you all on ReggieNet as well as the PDFs. Feel free to cut and paste out of that to send me just one page as your submission, because question number 2 does span over 2 separate pages again in that original notes file. So chop it and condense it down and scan and email that to me in the assignment location within ReggieNet. You'll see a quiz 5.3 location and get that into me by 8 a.m. on the 20th. And you'll see that that assignment location shuts down about 5 or 10 minutes later, so you don't have a lot of extra time to get that done. Get that done on time so that I can put that in the gradebooks for you.